astronomers have detected coherent radio wave signals emanating from a distant exoplanet. Is this finally a clue to life on this exoplanet? Or could it be something else? Let's delve into this story in today's video. Roll the intro. All right, folks. Today we're going to discuss an article published in Nature Astronomy. Yes, it's a very intriguing article because it talks about the detection of coherent radio waves on a distant exoplanet. At first glance, one might think we've found signs of life right away. After all, one of the ways we search for life on another planet, or what we call technosignatures, is by looking for coherent radio signals that aren't just noise. So when you see a headline like that, you might immediately assume that we've discovered life, don't you? But it's not quite that simple. Although it could be related to life as well, it seems a bit more complicated, so let's try to understand it better. Well, one of the essential factors for life to exist on Earth is our planet's magnetic field. What does it do? Earth's magnetic field protects our atmosphere, preventing it from being swept away by solar winds, which preserves our atmosphere, allowing us to live here. The magnetic field also acts as a shield against more powerful solar radiation, especially during major solar flares. So, the magnetic field is a crucial element for life to thrive on a given planet. Are you with me so far? If a planet is rocky, has liquid water on its surface, possesses various other characteristics, and also has a magnetic field, that could be very promising for life. However, detecting magnetic fields on other planets is quite challenging, to say the least. It's already challenging to observe exoplanets, let alone detecting their magnetic fields. This is where astronomers on Earth have very powerful radio telescopes. They theorize that the radio waves they detect, generated by the magnetic field of an exoplanet orbiting a star, could carry signals indicating the presence of a magnetic field. As I mentioned, the magnetic field is invisible, which makes it very difficult to detect on a planet. However, with the highly advanced radio telescopes we have today, it is possible to detect a signal that holds promise for this purpose. So, that's precisely what a group of researchers did. What did they do? They chose a red dwarf star called YZ Ceti, which has a known exoplanet, YZ Ceti b. This pair, the star and the exoplanet, formed an ideal combination because the exoplanet is very close to the star, completing its orbit around the star every 2 days. That's quite favorable. As the plasma from the star, YZ Ceti, escapes, it interacts with the magnetic field of the star and the exoplanet, generating a radio wave that can be detected on Earth. So that's exactly what the researchers did. They measured it using a powerful radio telescope, the Very Large Array. Just to remind you, YZ Ceti b is located 12 light-years away from Earth, and it's known to be a rocky planet. In other words, it's an ideal planet to search for life as we know it on Earth. These interactions, the high-energy particles being ejected, create auroras here on Earth. So how are auroras created? You have a coronal mass ejection, particles come to Earth, interact with Earth's magnetic field, get guided towards Earth's poles, and release energy there, which we see as auroras. The interactions between YZ Ceti b and its star also produce auroras, but with a significant difference. The aurora isn't on the planet itself. Do you know where the aurora is in this case? The aurora is on the star. Exactly. So, the researchers see an aurora on the star, which becomes a noise in the radio wave signal. However, it's not random noise, it turns out to be coherent in that signal. With this, the researchers conclude that YZ Ceti b must have a magnetosphere, because this interaction generates the radio signal in the star's radio emission. Researchers agree that while YZ Ceti b is the prime candidate for a rocky exoplanet with a magnetic field, it's not the only one. This could indeed be something quite common throughout the universe, and that's fascinating. So, When people talk about the possibility of life, we often focus on having water and being in the habitable zone, and these are undoubtedly crucial factors. As I often say, life is, in reality, a combination of numerous factors, numerous variables, and we may not even know how many variables are necessary for life as we know it to exist. Do you agree? One of these variables is definitely having a magnetic field. So, finding a rocky planet in the habitable zone with surface water and the right temperature is all essential. But if it lacks a magnetic field, it won't be of much use. Therefore, without a magnetic field, it probably won't have an atmosphere. And consequently, it probably won't have life. On the other hand, when you find a rocky planet with all these characteristics and a magnetic field, the chances of finding life increase significantly. It's truly an exciting piece of research, and what's even more intriguing is understanding how they accomplish this. They concluded that the interaction of charged particles blown by the star when they interact with the magnetic field of an exoplanet, especially one as close as this, affects the star. The measurements are taken on the star. By measuring the star, we can infer the presence of a magnetic field on the planet. In general terms, we call this an indirect measurement in science. We're not directly measuring the planet's magnetic field, but we're inferring its existence through another measurement, which is truly remarkable. So, as I mentioned at the beginning, when you first see this news, you might think, wow, we've discovered life, because a coherent radio signal must mean life. However, a coherent radio signal can be related to other things, in this case, the magnetic field, which can also be linked to the potential for life. Now, what the researchers want to do is search for this same signal on other known rocky exoplanets. This will become even more feasible because we're on the verge of inaugurating large radio telescope arrays. By the way, let me tell you something else. The next decade in astronomy is going to be sensational because we'll have the family of 30-meter telescopes, including the TMT, GMT, ELT, and the Vera Rubin Observatory. In addition, we'll have a significant family of radio telescopes. The Square Kilometer Array, known as SKA, is part of it, and the other part is located in Australia. So, we'll have these two large telescopes, Meerkat in South Africa and SKA in Australia, forming the Square Kilometer Array. This will create a vast array of antennas, and several others are set to be inaugurated worldwide, which will greatly aid this type of research. What type? Discovering magnetic fields on rocky exoplanets, which could indeed be a sign of life. Why not, right? This was the video I wanted to share with you on this channel today. I hope you enjoyed it. If you did, don't forget the YouTuber package. Share, favorite, subscribe to the channel if you're not already, and leave your questions or comments down below. Thank you very much for staying with me. Check out another video I've prepared for you. I'll be waiting for you there.